Hello students, in this session we are going to study the simply supported beam with UDL. Our aim is to find out the deflection and slope, and final aim will be to find out the maximum deflection. And as you know that for UDL the maximum deflection will be at the center. At this point, that will be the maximum deflection, and you know that for simply supported beam the maximum slope is at the supports. Suppose a point, this is theta max, and also theta b, wherever you want to see, this is also theta max, because it is uniformly distributed and on the entire beam. So theta max at A and theta max at B will be same, right? So our aim is to find out the y max and theta max, or you can say deflection on the entire as a function of x on the entire section, and also slope on the entire section, right? So what we are going to do, we are going to use this equation ei d2y by dx square will be equal to minus mx. This is the deflection equation. So deflection, for this deflection equation we have to use the bending moment at a distance x. So let us say take any section x at a distance small x from the one of the end like this. But for that you need the reactions. What will be the reactions? If this load is W kilonewton per meter, then the center load will be the load at the center. Load at the center will be this load. This load at the center will be W multiplied by the length is L, so this will be WL. So total load, concentrated load of this section, this entire beam will be W multiplied by L, this is because it has length L and the weight is W kilonewton per meter. So WL is the total length, and how the load will be shared by the reaction A and how will be shared by the reaction B. So here RA will be equal to WL by 2 and RB will be equal to WL by 2. This we have already read in our shear force and bending moment diagram, that chapter. So in that chapter we have already read, that's why I am writing directly here how to find out the reactions. So check in that chapter how to find out the reactions. You will get WL by 2 and WL by 2, the reaction for UDL on the entire beam which is simply supported, right? Now this is our a section x. Now what is the moment? What is the moment of this WL by 2? That is WL by 2 multiplied by x, and also this part of the beam, x part, this part will be having a load W multiplied by x at the center of this part, right? And this distance will be x by 2. This is Wx, and this distance will be x by 2. So what will be the moment? What will be the moment at a distance x? That will be equal to the moment of this RA and moment of this Wx, right? So moment of RA will be WL by 2 multiplied by x. So this will be WL by 2 multiplied by x, the moment of reaction A, and the moment of Wx. The moment of Wx, that will be Wx multiplied by x by 2, because distance is x by 2. So that will be equal to minus Wx into x by 2, so this will be Wx square by 2. So this is the bending moment, and it is valid. It is valid from A to B because there is no other load in between. So it is valid for entire beam A to B, right? So we can use here mx, the WL by 2 x minus Wx square by 2. So we can write this will be equal to minus WLx by 2 and plus Wx square by 2. So we have used this minus mx here, right? The value of mx, right? Now, if we integrate it once, we will get the slope. If we integrate it twice, we will get the deflection. So integrate it, you will get dy by dx, ei is here. So ei dy by dx will be equal to integration of this. This is minus Wx square by 4. X, integration of x is x square by 2, so x square by 4, plus Wx cube by 6 plus some constant c1. If we again integrate it, we will get the deflection, right? So this is a slope equation, slope. So again, if we integrate it, we will get ei y, integration of dy by dx is y, that will be equal to minus wl x cube by 3, so x cube by 12 plus x to the power 4 by 4, so this is w x to the power 4 by 4, it means it will become 24, plus c1x, and then again there is another constant c2, right? So this is the equation now, right? Now this is our deflection equation. Now we have to use the boundary condition. We have to use the boundary condition. What is the boundary condition? So boundary condition is that at x is equal to 0, the deflection is 0. At x is equal to L, deflection is 0. So at x is equal to 0, what are the boundary conditions? X equal to 0, deflection is 0. X equal to L, deflection is again 0. Put these two boundary conditions in this equation and you will get the value of C1 and C2. So what is C1 and C2? From here, solve it and you will get, try to solve it. Put the value of x here 0, 0, 0, you will get C2 as 0 because y is 0. So C2 will be 0 directly, we can see here C2 will be equal to 0. And put x is equal to L, L cube, L to the power 4, C1 L, you will get the value of C1 here, right? So what is the value of C1? Solve it and get the value of C1. I am writing directly the value of C1, WL cube by 24. W L cube by 24. So this is the value of C1. Solve it and you will get this value, right? Now we know the C1 and C2 now. Put this C1 and C2 in this equation and you will get the final deflection equation, right? So you will get the deflection as y will be equal to, put the value of C1 here, minus WL x to the power cube by 12, minus WL x to the power cube by 12, right? So minus WL x cube by 12 ei, this is one term. Another term is this term. What is this term? This is W x to the power 4 by 24 ei plus C1 is known to us, WL cube by 24. So this is WL cube x by 24 ei and C2 is 0, right? So this is the deflection equation, right? Let us check once, right? So this is the deflection equation. Let us say it is a equation number 2. Now slope equation, this equation, this is our slope equation. This is our slope equation. Say this slope equation number is 1, this is 2 and this is 3, right? This is 3, right? Now put C1, the value of C1 here and you will get the slope equation, right? So slope dy by dx means theta, slope means theta, right? So you will get theta, which is also equal to dy by dx. That will come out to be minus WL x square by 4 ei minus WL x square by 4 ei plus wx cube by 6 ei, wx cube by 6 ei plus C1 is this, WL cube by 24 ei plus WL cube by 24 ei. So these are the values, right? So this is the slope. So we have obtained the deflection and slope equations, right? Say this is equation number 4. So this is the slope and deflection equation for simply supported beam with UDL, right? Now this is the slope and this is the deflection for a simply supported beam with UDL, right? But our aim is to find out the maximum deflection and maximum slope. Where is maximum deflection? Maximum deflection is at this point, right? If we draw this curve, this is maximum at the center, this is y max, and the slope is maximum at this point, this is theta max, right? theta max, right? So this is theta max and this is y max. So theta max and y max will be y max will be at x equal to L by 2, यानी कि at center, right? At x is equal to L by 2 there will be y max. Put the value of x is equal to L by 2 in this equation. Here put x is equal to L by 2, x is equal to L by 2, x is equal to L by 2. Put here, you will get the y max, the maximum deflection. So put in equation number 3 and you will get the y max, and I am writing the final equation of y max. What is the value of y max? And you will get the y max as 5 by 384, 5 by 384 WL to the power 4 divided by EI. So this is the y max. This is obtained from the equation number 3, and this is very important. WL4 by 384 EI, this is the y max. Now finding the slope, maximum slope. Maximum slope will be at A or at B, right? Both points will be the maximum slope points. So theta max will be obtained at x equal to 0 or x is equal to L. Both ways you will get the same value. So theta max will be equal to, put the value of x0 here, x0, you will get this value. This value is the maximum value, right? Because x is 0, you will get this value, maximum value. So theta max will be equal to WL cube by 24 EI. So this will be WL cube by 24 EI. So this is the theta max, maximum slope at the support point, A point, right? So this is how we can obtain the deflection and slope as a function of x, as well as the maximum deflection and maximum slope using the boundary conditions and the given configuration of this system, right? And this is a simple supported beam with UDL.